there's many things that are now going around the water utilities. Which one would you say is the one that has been you have hearing most from the customers you have been visiting? Which is the top that they have in their mind?
Well, it's a variety of challenges. So what we did, we had the privilege 2 years back to make a deep interview with a number of utilities in Nordics. So we raised the question that what kind of challenges do they see and how do they find solutions for it? And obviously it depends a bit about the size of the utility itself, but I would say in particular they talk very much about the urbanization that is happening and have been happening obviously for decades, but they clearly see the impact of urbanization. Not only that people is moving into cities or out from certain places, but the same city can see both moving away from certain areas and into other areas. And at the same time, they need to both renovate the system that they have and the asset that they have, and at the same time build completely new living areas. So it's a mixture of challenges that they see.
Welcome to the Urbanista, where we discuss the water management challenges of Nordic cities. From safe drinking water distribution and stormwater collection to building sustainable urban living environments. Here is your host, Delphine Vesalo.
Hey, welcome back, Urbanistas. It's so nice to be back in your ears. Hey, if you work at a water utility or you are responsible for a water network, you don't want to miss this episode. This will be really insightful for you because we have a very special guest today. A guest that, knows a thing or two about this, about the challenges that the water utilities, the water network managers have on a daily basis. And we are going to discuss lots of interesting things, so you cannot miss this episode. So, who are you and what you do?
My name is Magnus Lundin, working with Uponor Infra. I've spent many years inside the company, and at the moment I'm responsible for what we call drinking water solutions inside Uponor, a wide assortment of products.
Magnus, it's so nice to have you today. So thank you for coming. And as I was saying in the introduction, there are many challenges that our colleagues, our partners in water utilities are facing at this point. There are many things that we can touch, but if we can start from somewhere, we know that urbanization continues. There are challenges with the cities growing faster than what the networks or the infrastructure can grow. Some of the old assets are getting older. These are difficult financial times. Of course, money is always an issue. There's many things that are now going around the water utilities. Which one would you say is the one that has been you have hearing most from the customers you have been visiting? Which is the top that they have in their mind?
Well, it's a variety of challenges. So what we did, we had the privilege 2 years back to make a deep interview with a number of utilities in Nordics. So we raised the question that what kind of challenges do they see and how do they find solutions for it? And obviously it depends a bit about the size of the utility itself, but I would say in particular they talk very much about the urbanization that is happening and have been happening obviously for decades, but they clearly see the impact of urbanization. Not only that people is moving into cities or out from certain places, but the same city can see both moving away from certain areas and into other areas. And at the same time, they need to both renovate the system that they have and the asset that they have, and at the same time build completely new living areas. So it's a mixture of challenges that they see.
Certainly, there's, as you mentioned, there's different challenges that the big urban centers are facing versus the small towns or smaller municipalities. So if we start with the big ones, with the big cities in the Nordics, and one thing is that, as you mentioned, people is moving because of economic reasons, because of businesses, many things. They are moving to these big cities, which are getting bigger and bigger and bigger every time. And how are they? How is the infrastructure situation there? Because for the most part, Nordic cities are old, so the installed infrastructure it's old as well, several decades already, or maybe more than 100 years. I don't know. So, on one hand is what's happening with this old infrastructure, and in the other hand is if they are growing, are they keeping up the pace to build new?
Yeah.
So how do you see this mix between trying to renovate the old one, and building new infrastructure for water distribution?
It is, as you touched here, it is a challenge. In many areas, more people is moving into to already populated area. And that means obviously both that the infrastructure itself is old and needs to be renovated, but also in other places where it may be so that the infrastructure is even okay, but its pipes are too small, so it cannot really cope with the increased population.
Because this is actually talking about old cities, which the design of the city itself, the streets and everything, it's small or it has a very reduced space. So if anyway we have to open the street and change the whole pipeline there in any given street, there's very reduced space to maneuver, to install things. So the street is what it is, the buildings are what they are, we cannot move them, of course, but then the whole system, the pipes and perhaps the different types of chambers that can go there, so they need to be adapted. So we are not talking about so much standard products, standard pipes, standard chambers that they can fit. There's the same type of sizes or dimensions. So there should be a need for very specific customization in those things.
Both for customized solutions as well as standard products, of course, but also lifetime is very important. I mean, when they do a renovation now in very dense populated areas, it's expensive, and the lifetime of the new products is obviously also very important.
The lifetime, so that has to do with the material, the raw material in which they are made of?
Material and design of the products, yeah.
Because which are mainly the materials that are now still on the use, the most popular materials you have seen?
Well, historically, there is a combination here of polyethylene, polypropylene, and PVC, but I think the trend goes more and more to polypropylene and polyethylene.
And what about other materials other than plastic? Specifically for water, drinking water distribution, are they still using, any other metal, concrete, or any other materials?
Metal is used in certain areas, depending on what they have been used to work with in the history. So the majority, I think, is polyethylene, but also cast iron and ductile system is used.
But then if we talk about the lifetime of those different types of materials, it's more likely that plastic lasts longer than, can you elaborate more? What would be more cost efficient?
Polyethylene as such have a very high lifetime if it's a certified material. It has more than 100 years lifetime, the raw material itself. So it's a good selection if the design of the product itself is as it should be.
So that is in the case of, they need to open up again the street because the pipes or the line going, the part of the network going through that street, well, it's needed to replace. That's very clearly renovation.
Yes.
And in terms of building new, I mean, they are building a new set of houses or new residential area or office business hub there. When there's this street that is very narrow and, well, they have to open, and because they have to renovate. They have to renovate all the infrastructure there. So that is one scenario. The other scenario is when they need to build completely new infrastructure, which means more money, more investment. So have you heard anything about what's the level of investment between renewing and building new?
I think that depends very much about the utility itself. But many popular areas nowadays close to water is heavily contaminated. And that's obviously a challenge itself, to be able to put new water pipelines into very contaminated soil. So there they need to have the special product for that purpose.
Pollution, contamination, that is one of the, I mean, we may not fully control, that is completely out of our control, either if the water or the water pipeline needs to go through a land which is contaminated because whatever industrial activity was there before. So that is one aspect of pollution. So is that, how common is that situation? The underground is polluted. I mean, you are in the south of Sweden at the moment. We are in Finland, but in the rest, at large in the Nordics, how often is that?
It is quite common, especially in the bigger cities and in those former industrial areas which may have been closed down, and new living areas is growing up. In those places, there is quite often problem with contamination in the ground. But there are solutions for that purpose as well, so that can be handled.
Actually, yes, because if we do not know exactly what is the situation of the ground down there, then what do we do? Which type of pipes would you suggest are the best ones to install it? Whether we know that it's polluted soil or we have no idea what is down there?
Yeah. So normal plastic pipes is not perhaps the best to select in those places. So it should be with a barrier layer. So in that respect, certain plastic pipes is very good with fully welded seam. Or alternative is also ductile iron, which is having this barrier solution.
So a specific pipe with barrier or specific barrier protection, which may protect against anything or everything. So what we could find down there, I mean, residues of previous industrial activity can be oil, can be
oil, diesel, or different kind of petrol components.
Hydrocarbons. I mean, if it's oil-based or kind of oil-based materials, is hydrocarbons. So then the pipe needs to be quite resistant or certified, actually proven that is resistant for that.
And have to ensure that it has the barrier that those pollution or contamination will not be able to penetrate the wall of the pipe.
Okay, that's one. Okay, when we don't know if the soil that we want to put the pipeline through is contaminated or not. Okay, we need to ensure that. What about the source, the water sources? That because we are talking about pollution. So whether the water comes from a surface source or is like very deep inside of the ground, the water mantle. So the water down there may not necessarily be as clean, or the water quality may not be as good, or What have you seen
True.
in the different?
What the customers told us, because we very much discussed that topic in this interview series we did, and they said that they are in general not so impacted on, let's say, the waters as itself. So there is enough of raw water for their need. But the problem is that the 10 years back or 20 years back, the quality level was very stable. But due to climate variations with very dry periods as well as heavy rain, it has impacted the raw water. So it's less stable than it used to be. So that means that they need to handle the preparation of drinking water in a different way than historically.
So it's not just extracting or collecting, how is it? Yeah, the water it needs to be prepared, the water. So what that preparation entitles? Is there?
It depends what the water source is. If we look at Sweden, for instance, the majority of the water comes from surface water, so lakes mainly.
Mm-hmm.
But there is a number of groundwater works as well. So the majority of the waterworks itself in numbers is actually groundwater waterworks, but the majority of the volume comes from surface water. So it's a bit contradictory in that respect.
But if the water quality is not good or not as good as it should be, so then what can we do, or how can we help once the water is extracted, or if it is surface water, as you say, most of it, then what is this preparation of water entitles? Is a chemical process? Is a physical process? Is there any way we can help them?
Yeah, it is. So groundwater, which basically have a relatively good quality, but very often have a very low pH. So it's a bit acid in that respect. And at the same time, it have carbon dioxide, manganese, iron is quite common, especially in certain areas of the countries. So here we can help them by certain products that we have in our portfolio, which have been developed now, partly thanks to this interview session. So what we do is that we mix the water that comes from the groundwater. We mix it with in an aeration process. So we get dissolved, reduces the carbon dioxide of the water, as well as certain solvable iron and manganese components as well. But by that, the pH also goes up to a certain level. In many ways, that's not enough. So from that point, we have also an alkalinization step, meaning that we let the water pass through a limestone filter. It's a patented solution that we have to increase the pH even more. And that seems to be a very big interest. And we have been delivering those products for almost 20 years inside our group, but not in all markets. But what I hear now from the customers is that they are extremely curious and interested in this limestone alkalization, because it's a safe process. You don't need to handle it so careful as other methods. And there is no risk of, let's say, over creating too high pH, because a very high pH can also be very hazardous and lethal, even if it becomes too high pH. But with limestone, there is no risk because it's a passive product and process. So whatever you do, if you have an electrical failure, for instance, stopping the process, the pH will never go up above 9.5, for instance, which still is very much on the safe side.
So it's passing or extracting this water that originally comes more on the acid side and alkalinize, is that a word? So
Yeah.
alkalinize the water, but this doesn't happen inside of the pipeline. So this lime stone is where it is another
It's
chamber.
a tank solution that we provide.
Okay.
So it's can be built above ground or below ground, and it's based on the Veolite solution that we have. So Veolite is a very good technology for this purpose. We can build different kind of diameters of the tank, with different heights, and it's a very safe technology in that respect, that we can ensure completely tight and watertight products, so nothing leaks in, nothing leaks out from the tank.
The material itself and the process to produce is that certified for drinking water, to handle drinking water?
Yes. We only use certified material for that purpose.
All right. So then, from the extraction of the water, or even if it's just collection when it comes from surface sources, this preparation of water, and then let's say if it is a lake, maybe not that close to the city, so then we still need to move it. Of course, move it a few or several kilometers, I don't know, to the city. What is the next step there that we have? Because
so
we store it, and then you have to increase the pressure, I guess. It's a matter of volume.
But before that, so a waterwork want to have a stable process. It doesn't want to increase and decrease the capacity utilization of the waterwork. So for that purpose, the waterwork is usually producing water towards a reservoir tank. It's a special kind of tank that hosts the water and should be able to cope with the different need that is in a city. So in the morning, for instance, when everyone takes their showers, or in the evenings, when everyone started their washing machines or start to cook food, etc., then obviously the need of water is increasing, and at night time it goes down. So therefore, this reservoir tank is used to cope with the variation through the day.
To stabilize, actually, because if the water coming from the source comes at different times, at different volumes, with different pressures, I can imagine in this reservoir tank we store it, yes, but it can get stabilized, normalized.
Yes.
So it's constant. The flow that comes out of the reservoir tank goes wherever it has to go. So that's the main point of having these reservoir tanks, that depending the demand for the city, they can be how big they can be, or maybe there's a series of reservoir tanks. How big they can be, the capacity of this?
The biggest tank we can produce in one shot, if I say like that, is a bit bigger than 200 cubic meters. That could be delivered directly to a customer and installed. But usually the tanks are much bigger than that. So then there is several of those tanks, or if the customer only want one big tank, then Uponor can also go and do the final installation at site.
200 cubic meters. So, but then is maybe, as you say, maybe one big one, or two or three
in parallel,
interconnected, or part of the same reservoir facility, let's call it. So that depends, but it's fully customizable. So depending the need, it can be done in fulfilling the specific needs.
And the good thing is that since we weld all this together, it becomes physically one tank in the end, without any joints or so. So it's a safe product for many years to come.
All right. So then once we have this, or we ensure this constant flow, constant volume getting out of the reservoir tank, if it needs to travel quite some significant distance. So what's the next step there? What can we have? Is it a matter of to keep that flow and the volume? Is it we need to increase the pressure, or How does that work there?
It depends a bit where the city is compared to the waterwork. Very often you need to raise the pressure to and transport the water, for instance, to a high point reservoir as well, like a water tower. So that means that you need a pressure boosting station. And that station have the responsibility to increase the pressure enough to transport the water to another reservoir. It could also be so that it's responsible to elevate the pressure to distribute the water to a certain area.
To elevate it to these high water towers, or also maybe to complete the trip if it is going up a hill, or is there any other natural obstacle?
Yeah. So you need a certain pressure to get the water distributed to all the consumers. I mean, you have a massive amount of consumers in a city, and for that purpose, you need to have a internal pressure of the water compared to the position where the consumer is.
And then once we pass the other side, once we go to the other side, or once we have this water tower, okay, now it's coming out, it comes with a lot of pressure. Then if we, on one side, we increase the pressure, at some point we need to reduce it somehow, somewhere, because otherwise the end consumer will, of course, they cannot receive on their own home tap like super high pressure.
Yeah. So that also depends where the consumer lives. So if the consumer lives in a high position, then it doesn't need to be reduced. But if the consumer lives in a very low position in the city, then they will probably get too high pressure. So that means that there is need of also reducing the pressure in those points. And there is a solution for that also. It's called a pressure reducer or pressure reducing chamber.
With all this super high pressure, I mean, the pipes on their high pressure, of course, from inside to outside, there should be at some point some risk of leakage, leaks here and there. And of course, with all their infrastructure, I may assume that is even worse, the problem. So where we are on this, or how can we prevent or deal with this leakage rates?
So this was also pinpointed in this interview with the customers that we did. And depending on what city it is or what town it is and what country it is, the leakage rate differs. So in Denmark, the leakage rate usually is around 10% or just below 10%. That's maybe the average leakage rate in Denmark. In the other countries, Sweden, Norway, and Finland, have a higher leakage rate usually, and even small cities have extremely high leakage rates. So it very much depends what place, how many meters of pipes, and how big organization does the utility have.
Talking about high leakage rate, so what? Of course, without naming any names, but how high are we talking about? How much of that water is getting lost? Like 20, 30, 40%, 50%? How much is high?
As I said, it differs between place to place, and I think if I say like this, in average, I think in the Nordic countries it's about 15%, maybe close to 20% in average. But in certain smaller towns, especially with let's say a big network but not so many inhabitants in the city, they could have like 40% leakage rate.
Anyway, 40, even 20. I mean, 20% of the water that was supposed to be delivered, 20% is lost.
Yeah.
So, I mean, that is quite a financial impact, significant financial impact for the water utility, I guess, because then, I mean, all the effort to extract, prepare, and then deliver, and halfway 20% gets lost. Yeah. I mean, is there a way to quantify that financially? I don't know. This is because hey,
and it's not
it's a lot.
it's not only water. I mean, it's also chemicals for the treatment. It's electrical energy for pumping and boosting the water pressure. So it's and especially with the electricity cost that we have been facing the last year, it's a substantial part of the cost structure.
So
and it
this,
goes away for basically no use. You don't get anything for that money.
yeah, that's what I'm thinking, because this is a significant like economic loss for the water utility. They're losing literally money
Yeah.
when this, I mean, in all aspects, the actual water that is leakage, and as you said, all the consumables, the chemicals, and etc., and the electricity that they use to, of course, to move water from one place to another. So this is a significant, could be a significant economical impact on the finances of the water utility. And
when we have been discussing this with customers and interviewing them, there is obviously different costs for different utilities, how much 1 cubic meter water production and distribution is. But it seems to be in the ballpark of 40 to 50 euro cent per cubic meter.
I mean, it only needs a little math and just multiply and then along the year. So that's what I mean. That's significant. So it's in the best interest, in the best financial interest of the utility to keep, of course, a low leakage rate and to keep in shape the whole network. Now, easier said than done, of course. Yeah, this is not a perfect world, and if we are talking about financial situations, yeah, well, the whole world is currently going through difficult economic situations, and some countries more than others. But I guess that this is one key thing. So the profitability of the water utility should be top of mind.
Yeah.
So then, also for in terms of investing more money or reinvesting, should I say, in renovating the areas that they should do it. So that's, I mean, there's no unlimited amount of money, right? So then how they are dealing with this? I guess that big cities may not have that problem, but maybe small cities or small municipalities maybe a bit money constrained.
I think they all have their challenges, but I think the smaller utilities have even bigger challenges because they do not have so big organization, and also the taxationable income in the utilities is not that big. And if you look at less dense populated areas, when many people live more on the countryside, it's more meter pipes per inhabitant in general.
Because if this, yes, sorry, go ahead.
So if many people lives in a very dense populated area, there is not so big needs of many meters of pipes. So it's easy to have control of that network. But if people are spreading out, which has been the case historically, then obviously there is also bigger network.
So whether it's because of the size of any given municipality, whether it's because of their good or bad financial situation, but if there's limited resources, so the small utilities overall have limited resources, then I guess they may need extra support in terms of advising, in terms of helping them understand how their network is behaving. Is there something we can do to support them?
Yes, I mean, in general, monitoring the network is already a big advantage, knowing where the leakages are, because then the customer can also use that knowledge to renovate the network where they have the biggest problem. And this is something that is ongoing, and many utilities have been putting in flow meters in the network for many years. But again, the one with less resources may be a little bit later than others.
Right. So then, well, that's yet another challenge that some expert advice, some expert extra support on that. That's always welcome.
Yeah.
Because there's also, as you said, there's the financial pressure. There's the different types of challenges, whether it's pressure or leakages that go along the network. Literally, the other day I was walking where I live outside of Helsinki, and there was this big open street, and I went, okay, well, I guess what they are doing. And yeah, effectively they were unearthing or taking out some of the pipelines. But the thing that I got a bit surprised is that they have certain type of brushes, because they were kind of brushing inside of the pipe, and that was clearly drinking water. But what it came out of that didn't look too much like potable water or actually for human consumption. It was quite disgusting. So still, they need to do this type of maintenance to clean inside of the pipes. So is that frequent?
It happens, or it's done maybe not on a regular basis. It probably depends from utility to utility, but cleaning or pigging the network is done on a relatively not frequent, but maybe every 5 years or a bit more than that. And as you said, it doesn't look very good, that water, because there is a lot of sediment and debris inside the pipe, maybe corrosion of old metal pipes, and all that comes out when they do this pigging or cleaning of the pipe.
Because these are all the inside of the pipe, these are all the residues that accumulate, as you said, after several years, they accumulate there. But no matter the pressure, so they still, those sediments still don't move. So the pressure of the water is not enough to like wash them out.
Yeah, true.
So it needs a mechanical process, or it needs some
it's
physical
usually a
process.
plug that is inserted into the pipe, and then that plug, usually a rubber plug or something, is then going through the pipe and brings all these residuals and sediment and non-wanted stuff to get loose from the pipe, and then it's flushed out at another point.
But hey, if the pipe inside this type of this pigging, this cleaning inside, and this needs to be done well after a few years, they were opening the entire street to do that. I mean, of course, deviating the traffic and etc. So is that? I mean, can it be a better way to do that? Other than open again the whole street or the sidewalk to get to the pipe and then open.
Yeah,
because that seems like a much significant investment.
Because the cleaning itself takes only maybe an hour or a few hours, depending on how big distance it will be cleaned, and the size of the diameter of the pipe. But the preparation, as you said, cutting the pipe, etc., excavating, that could be 2 days' work.
2 days of work and 2 days of investment. Yes, exactly. So what can be done better?
Yes. So what we propose is that when you do an excavation, to be able to do the pigging, then you should also set in the logical product pigging chamber. So that is like a crossing of the pipe, where you can enter or exit debris and the plug itself. So then you don't need to excavate more than once. So next time when you do a cleaning, then you open a plug or a valve, put in this cleaning plug, and then you shoot that out at an exit point.
So it's instead of opening again the whole street, so it's kind of an entrance, a chamber that is already there, hidden or not, but it's you only go and open that part, not the
Exactly.
entire, block of or street.
Yeah.
And from there you can insert all the cleaning equipment.
Yes. And there is specialized companies, contractors doing this kind of cleaning. So if they just have the entrance, they have all the machine to do the work itself.
All right. Then this, clearly, financial impact, positive financial impact, and keeping the status of the network in good shape. So
Yes.
That's another thing that maybe the water utilities may want to may want to think about. And but what about the general understanding of what is happening at any given point in their network? You raised the point of they have been installing flow meters for many years. Is that enough to really know where the leakage is happening, when they may happen, where in which part of my network I may have better quality than in others?
Depending on how you segment your network, you can get better or less good insight where the leakage is happening. So you need a number of those measuring chambers or flow meter chambers, and you divide your network into something called district metering area. So DMA is a popular word for that purpose. And if you have segmented your network and you have flow meters in those locations, then you can at least see in what DMA you have the leak.
Right. So there's quite a number of challenges here. If we can summarize, is on one hand the urbanization that continues, and it will continue most likely as the economic activity develops, and how fast or how cost efficient the utilities are dealing with that, whether it's renovating or building new. Second challenge is, as you mentioned, due to all these climate variations, the raw water, the water coming from those sources may or may not be anymore the best quality, may not be the same in the same constant flow. So we need to keep adapting to those, or water utilities need to keep adapting to that new reality, new ways of preparing the water. You mentioned the pH, the level of acidity, the level of alkalinization or aeration, to ensure the constant flow at different hours of the day, because the peak of the demand is different. If we have these reservoir tanks, that could be a way to preserve. And since we don't know always through which type of ground the drinking water pipeline should go, well, barrier pipes should go I would say the default or the only choice, pretty much. So to ensure that the water going inside will not be contaminated in any way. Managing the pressure in different ways, depending the geographical obstacles, depending the type of demand you have. Cleaning the inside, the maintenance of inside of the pipes. So actually, there's a huge amount of things that the network managers need to think. And of course, the materials, they should be certified for drinking water. I have also heard something about the directive of the drinking water. That's something that is evolving as well. I don't know if it's only in Sweden or it's across the Nordics, or maybe in Europe.
It's a European directive, and it's slowly coming into force. So that will also affect how the utilities, what kind of products and material that they use, which is in contact with drinking water. And there, I would also say that plastic pipes and also tanks and chambers for made of plastic is a very good choice because they have already all the certifications to be allowed to be used in drinking water.
Because the certification needs to be for the pipe, for the chamber, but also anything that goes inside the flow meter, any other thing. Everything should be certified, right?
Every material that is in contact with drinking water. To
Right,
safeguard that we drink healthy water also in the future.
Well, there's, as we said, summarizing all these challenges. Well, there's a lot of things to consider to deliver safe and clean water to the end consumers, to you, me, all of us, which are of course consumers of water. There's many challenges. What would you recommend, if any, after all these conversations that you have had outside there with many water utilities? What would be the thing that you would recommend them to do, or which area is the one that you consider they should be focusing mostly?
I think a good way to handle all those challenges, not to put ourselves too much into the center of the solution, but familiar yourself a bit with Uponor's assortment of drinking water solution. I mean, most customers know that we are famous or known for production of pipes and fittings. But if we see the entire portfolio from raw water to basically to the consumer's tap, it's a I must say I'm proud of this portfolio, and that's very one way to understand when you do renovation or repair or expansion, what should you care of when you do the work, because you invest a lot of money and you want to have as high lifetime as possible for this investment.
Exactly, the lifetime investment, which is an investment made with public money, with taxes, with your money, with my money, with everybody's money. So I guess that's in the interest of everyone, how cost efficient this distribution from source to tap of drinking water can be. So Magnus, thank you very much for sharing your wisdom today with us.
Thank you.
As we evolve and as we see how things are moving, maybe we should catch up in a couple of months or 3, or I don't know, so to see what you have been listening from outside there. That would be really insightful, so we can continue sharing more insights here.
I would be happy to do that.
So thank you very much, Magnus. Thank you very much, Urbanistas, for listening or watching, depending where you are. We will continue with more insights and more things for you. Keep up the good work, and thank you for watching.
Thank you.
Thank you for listening to the Urbanista podcast, a production of Uponor Infra, the leader in sustainable infrastructure solutions. If you found it interesting, why don't you share it with your colleagues? We all together can move our industry forward.